Okay, so last section we'll look at is 8.1. We're actually going to split it into two sections. We'll do part now, and then we'll do part of it next time we have class. So if you're dealing with triangles where you don't have a 90-degree angle, then that means you can't use Pythagorean theorem. Pythagorean theorem only works when you have a right angle. You also can't use SOHCAHTOA, right? Opposite over hypotenuse, adjacent over hypotenuse. Because the only way you have a hypotenuse is if you have a 90. No 90, no hypotenuse. So the triangles that we're going to be dealing with are called oblique. There's two kinds of oblique triangles. There's acute and there's obtuse. An acute triangle is where all the angles are smaller than 60. So one example would be like an equilateral. Every angle smaller than 90. Sorry. And then obtuse is where you have one angle that's bigger than 90. Could you have two angles that are bigger than 90? No, because all the angles have to add up to what? 180. So if you had two that were bigger than 90, it's not going to happen. So regardless of what kind of triangle you have, I don't draw it to scale. I pretty much draw every problem like this when I have an obtuse triangle. It's not really important that you draw it to scale. What is important is that you put the right letters across from each other. So we're still using A, B, and C to represent the sides, just like we did in a right triangle. But we're using one other Greek letter that we didn't need before because it was always a right angle, but now it's not. So we got to give it a name. Does anyone remember the name of that Greek letter? The one that's always across from A? Alpha. Yep. And how about that Greek letter? It's across from B. Beta. And now we've got a new Greek letter that's across from C. Yeah?
Gamma.
Yeah, that's gamma. So alpha, beta, gamma. And you can draw your triangle any way you want as long as you maintain those relationships. Keep A across from alpha, B across from beta, and C across from gamma. Now, technically, you don't even have to use those letters, but if you do, it just helps to organize things so you don't make a mistake. So, to solve a law of signs problem, there's 6 things that you have to find. You have 3 sides and 3 angles. Well, in order for you to solve a problem, I have to give you half the information. Okay. So out of the 6 pieces of information, I will always give you 3. Your job will be to find the other 3. What kind of information you're given is going to change whether you use this law to solve the problem or the next law we're going to learn, which is the law of cosines. This law, okay, the law of sines, is used for 3 different types of problems. If you are solving a problem where you have to figure out 2 angles and a side, that's a law of sines problem. And even within 2 angles and a side, there's 2 ways you can do it. You could do something like this. This is an angle, a side, and an angle. Angle, side, angle. What makes it angle, side, angle is the side that you know is between the 2 angles. It's the side that connects them. Okay. Compared to something like this, where let's say you had a side, an angle, and an angle. Same pieces of information, but the side is in a different spot. It's one of the sides that's not between the 2 angles. It doesn't connect them. Regardless of which kind of problem you had here, you use law of sines for both. The last type, little different. Okay, this is when you have a side-side angle. So, side, side, angle. So you know two sides, and the angle that you know is not between the two sides. That would be SAS. We can't do SAS with the law of sines. That doesn't work. Right? So if you have two sides, they've got to give you the angle that's not the one between them. That's the one between them. If I gave you that one, we would use law of cosines. But we're not going to learn that yet. Okay, so to solve any of those three types of problems, we're going to use the law of sines. And those are all the types that you use law of sines for. You do not use it for anything else. Okay, if you're wondering what else is there, I already said one, SAS and SSS. Those two types that I just said, we won't look at for a little while. Okay, so what I'm going to do is I'm just going to give you the law of sines. It's not that hard to really explain where it comes from. It usually takes me about 5-6 minutes, but I'm going to skip over that part and just show you the formula. So the formula is actually it's a series of fractions. The first fraction is sine of alpha over A equals sine of beta over B. And now based on the pattern continues. Does anyone think they know what the third fraction would be? Yep. Sine of gamma over C. So the way I look at this is that I look at that as the first part, the second part, and the third part. Whenever you're using the law of sines, you only use two parts of this formula at a time. Either the first two, the last two, or the first part and the third part. And you're trying to find one specific thing. So what ends up happening is you end up with a proportion every time, and you cross multiply. Once you cross multiply, that's it. That's how you find what you're looking for. You can still use the fact that all the angles in the triangle add up to 180. That still is true. But what did I say you can't use anymore that we used to use in right triangles? You cannot use the Pythagorean theorem. That doesn't work. And you can't do like the SOHCAHTOA. There is no opposite, adjacent, and hypotenuse. Unless you have a 90. Then you could. Okay, so let's look at, we'll do, I think, 3 examples, and that's it. Okay, so the first thing we want to do is draw this triangle and make sure that it's one of the 3 types that we said we can use law of sines for. Okay, so I'm going to draw it. Again, it's definitely not to scale. I'm going to put A over here. And then I'm just going to put alpha across from it. I'm going to put B right there. And I'm going to put beta across from it. I'm going to put C here and gamma across from it. So I've labeled everything that I know. If I wanted to describe this triangle using the 3 letters, like A's and S's and A's, what kind of triangle is this one? Look at the information you're given and look at where the side is in relation to the 2 angles. Yep.
Angle, side angle.
Nope, this one's not angle, side, angle. To be angle, side, angle, you would have to know side C. Because then the side would be sandwiched between the 2 A's, 2 angles. Yeah?
Angle, angle, side.
Right. You know 2 angles and a side, and the side is in between the 2 angles. If you write it this way, it doesn't really matter. That's the same thing. Angle, angle, side, side, angle, angle. All right. The point is, it is one of the 3 types that falls under law of sines. Okay, so let's make a table. And in the table, we're going to fill in everything we know. and then I'll put boxes around what we need to find. So A we knew, beta we know, and alpha we know. So you need this, this, and this. Another way that you can tell that a problem is law of sines without actually drawing it is to make that table. Look at the table, and if there's a row in it that's full, then that means you can use law of sines. I have a full row, the top row. It's got everything in it. I said there's other kinds of problems we're not going to solve with law of sines. And if you remember, one of those I said was side, side, side. Well, if you knew a side, and a side, you wouldn't have any row with both pieces of information. That's why you wouldn't be able to solve side, side, side. Okay, so another way, look at the table. Full row, use law of sines. Okay, when we solved right triangles, we usually could avoid using things we calculated to find other things. Why was that a good idea? To avoid using something you found to find something else. Yep.
All your mistakes are gonna compound.
Yeah. Yep. So it gets worse if you made a mistake, it just gets worse. Well, with these kind of problems, you can't always avoid that. You're going to have to use things that you find to find other things. For example, we're going to have to find gamma. And there's no way to get C without using gamma. Right? So if you make a mistake finding gamma, you're automatically going to get C wrong as well. But B has nothing to do with C or gamma. So you could still get B right. So there's a little bit more reliance on things that you find in these kind of problems. So let's start with gamma. How much is gamma in this case? Yep. 100. It's 100. Yeah, and that is right. So we have the correct thing to use when we want to find C. If we had put anything other than 100 for gamma, then C is automatically going to come out wrong. Unless you make some magical mistake that somehow makes it come out right, but it's probably not going to happen. All right, so now we're going to pick two parts of the law of sines. One part that you pick, you have to know both the top and the bottom. And the other part that you pick, you only need one. Right? So which row here has everything in it? Yeah? A and alpha. So I'm going to start by, we'll decide what we want to find in a minute. We don't even need to write what we're going to find yet. Let's just fill in the left side. Sine of alpha divided by A. Regardless if you want to find B or C, that's how it's going to start out. Right, let's find B. So we used this, and we're going to use that. For now, we're not going to use gamma and C. We might need it later in the problem, but not for this part. So take what we just had and set it equal to sine of beta over B. Sine of 60 over B. And now, solve for B. Okay. How do we solve a proportion? What do you have to do? Yeah. We cross multiply. So we've got 4 sine 60 equals B sine 20. Okay. Now I've got one step left to get B by itself. What would be my last step? Yeah. Divide by the sine of 20. Notice I haven't figured out what the sine of 20 is. And I'll never know exactly what the sine of 20 is in this problem. What I am going to figure out is all of this at the same time. 4 sine 60 divided by sine 20. And that's the answer for B. Okay, all of these problems are in degrees. So make sure you're always in degrees for this section. 4 sine 60 over sine 20. There's there's no way to reduce that, like, and try to plug in smaller numbers, like, say you try to reduce 60 and 20, you can't do that. So just type in the whole thing like that. So B is 10.128. And now we're going to find C, pretty much the same way we found B. Can I do Pythagorean theorem to get C? No. If I use Pythagorean theorem, you're assuming this angle's 90. It's not. So I have a choice now. I have two rows that have everything in them. I could use either row to find C. Which row should I use? Yep.
A.
Yep. How come?
Because it was already given, and
Yeah.
you have to calculate B, so it might not be accurate.
Right. So at least if we made a mistake finding B, we're not going to use it to find C. Right. So now let's find C. You're going to start the same way. Sine of 20 over 4. Equals sine of 100 over C. Once you get better at cross multiplying, or you're probably already pretty good with it, you can just do it all in one step. C is going to equal 4 sine 100 divided by sine 20. If you don't want to do it all in one step like that, you can do it in two steps, like I did right here. But in the test, I'm fine if you just do the cross multiplying in your head. Now, before I fill it in, what do I know about side C compared to the other two? Yep.
Larger.
Should be larger. Okay. This is the biggest angle. This is going to be the biggest side. You can't say, oh, because this angle is 5 times bigger than that angle, this side's 5 times bigger than that side. No, the graph of sine isn't a straight line. If it was, that would be true. But you just have to figure it out by typing it in. It'll be larger, but it won't be larger than 14.128 because these two sides added together have to be bigger than the third. It's always true in any triangle. So it's somewhere between 10 and 14. That's all I know. Right, let's see what it is. 4 sine 100. Make sure you close the parenthesis. Divided by sine 20. And we get 11.518. Okay. That's it. It's law of sines problem. So this would count as 3 questions on the test. 1, 2, 3. And it would be a short answer problem, just like that. I'd have blanks for you to write in those 3 answers. Okay, so it wouldn't be multiple choice. Questions on that one? All right, so that was angle side. Let's try this one. They already gave you a picture, so we can cut that step out. What kind of triangle is this one, using the 3 letters?
Angle, side, angle.
This is angle, side, angle. If you go back and look at the notes, that's still one of the 3 types I said to use law of sines for. Okay, so I'm going to make my table. If you don't want to make a table, you don't have to, but it's kind of helpful. All right, now they didn't label these 3 things, but I should be able to infer which one is which from their placement in the diagram. What's the 45 degrees? What is that?
Alpha.
It's across from A, so it must be alpha. 40 is across from B, so it must be beta. And then the 4 is across from gamma. So what's the 4? C. Now I said that when you set up your table, if you look at it and this happens, then you can use law of sines. What should happen in that table? But I don't see it right now.
You
Yeah?
should have a full row.
I should have a full row. So you either should have a full row or you can find something right away that would make you have a full row. Yeah?
Find Is it gamma?
We can find gamma right away because we have the other two angles, and then we'll have a full row. So these two angles add up to 85. So how much would gamma be? Yep,
95.
95. Now, it's very important, even more important that you get gamma right in this one than you did in the last one, because this row is going to be used for everything. So if you got gamma wrong, now you're going to get A and B wrong, because you're going to have to use gamma for both. Questions on it? Okay, so let's set it up to find, you can do A or B first, it doesn't matter. The only thing you had to do first was gamma. So let's find A. On the left side, it doesn't matter where you put all the information that you know. You can start on the left or you can start on the right. Let's start on the left. So Tori, what could I fill in on the left-hand side where I know the top and I know what goes in the bottom?
You could put the sign of 95.
Yep. Doesn't matter where you put it, just put it on one side. And now you're finding A. So what's going to go on the right side? Yeah.
Sign 45 over A.
Sine 45 over A. All right. And now when you cross multiply, can anybody tell me all in one step what A will be? What times what divided by what? Emma?
4 sine 45 over sine 95.
Sine 95, and that's a 5. Yep. That's it. So let's see what we get. 4 sine 45 divided by sine 95. I keep saying to close that parenthesis because if you don't, you'll get the wrong answer. 2.839. Okay, now I know a little bit about what B should come out to. B is the smallest sign, so it has to be less than 2.839. But beta is just a little smaller than alpha. So B will probably be just a little smaller than A. Okay. All right. So now let's find B. Since I have a choice now, which row I use, two of them have everything in it. Which row should I use? Yeah.
Oh, yeah.
Yeah. Always use the one that was given. Well, it wasn't given, but at least it doesn't have decimals. So sine 95 over 4. And now it's sine 40 over B. When you solve it, it's going to be exactly the same. It's exactly the same proportion as what you had on the left, except replace 45 with 40, and that's your answer. So it's 4 sine 40 over sine 95. Sine 40 over sine 95. And now, just to save time, what I can do is just bring up the last thing I typed and then just change that one number. I don't know if that's quicker than typing it from scratch, but 2.581. Right, so B is 2.581. So we have to find that and that. Okay. Any questions on that side? That's angle, side angle. Okay. So, the last type. Out of the three, this is the type where you've got to be a little careful with something. You have two sides and an angle. Side-side angle is the only type out of all 5 types we're going to study. We've studied 3 today. We're going to study 2 when we do law of cosines. This is the only type that can have one solution, just like every problem we've been doing. You solve for what you need to, and you just get one answer. Or you could end up with 2 solutions or no solutions. You already know what you need to know to figure out if there's a second answer. It has to do with that chart right there. And it's going to deal with inverse sine and looking for where it's positive. So once we find one answer, you can use that chart and already figure out the second one. But we've got to keep in mind we're working in a triangle, so there's certain restrictions. The angles have to add up to 180. That's important. So when we go through, you can very easily tell if it's a one solution or two solution. And if it's a no solution, you can tell that because you get an error. It's like you try to take the inverse sine of something like this. And you can't do it. So when it's a no solution, that's the shortest type. You know right away. All right, let's try this one. This is the last one. Okay, so A is 3, B is 2, alpha is 40. Now, I can tell that this is side-side angle without even drawing it because I can look at the table and I see a row with everything in it. That tells me that it's law of sines. The other thing I see is a row with nothing in it. That tells me that it's the side-side angle case. We didn't have that happen in any other problem. We always had something in every single row that we could find. It's impossible to get C, and it's impossible to get gamma right now. The only way you can get something in this last row is to figure out something else first. So side-side angle problems have to be solved in a certain order. You have to get that first. And then once you have 2 out of 3 of the angles, then you can get the third angle. And then once you have gamma, you can finally get the last side. You can't do these in any other order. It will not work. So let's find beta first, using the top row, because we have everything in it, and the middle row. Forget about the bottom row. It's totally empty. It doesn't help at all. So you can't use it right now. Okay, what would go on the left side of that proportion if I want to find beta? Yeah.
The
Sine of 40
over 3.
over 3. And what goes on the right side? Joe?
Sine of beta over 2.
Yep. If you set up your proportion and you have spots with 2 variables, you did something wrong. You should only have 1 variable and 3 numbers. Okay. And now cross multiply. 2 sine 40 equals 3 sine beta. Now, before I even keep going, what's different about this one? There's something different here that didn't happen on the first 2. Yep.
The sine is the variable.
Right, the variable is inside a sine function. The variable is an angle. It's not a side. It was a side in the other 2 problems. Right? So we want to solve for beta. 2 things I need to get rid of. What's the first thing I could do on each side that would start to get beta by itself? Yeah? Divide by 3. So it's 2 sine 40 divided by 3 equals sine beta. And now I need to get rid of sine. So how do I get rid of sine?
Inverse sine.
Inverse sine. So inverse sine of what's on the left. Inverse sine of what's on the right. Now we type that in. It's the inverse sine of 2 sine 40 over 3. Second, inverse sine 2 sine 40, close your parenthesis, over 3. Unless I typed in something wrong, this is not a no solution problem. I know that because I just got a solution. 25.374. So that's, I'm going to write that down for beta. But what I'm going to do is I'm going to write it in the box kind of up higher. The reason I'm going to write it up higher is because there could be a second answer. So we're looking, if there's a second answer, we're looking for a quadrant where sine, if I go back to the step we had before, it said sine of beta equals all of that stuff. If you typed in 2 sine 40 over 3 and just hit enter, what kind of answer would you get? Positive or negative? 2 times the sine of 40 divided by 3.
Positive.
Positive. Yep, it would be a positive answer. We got an answer of, what did we get? 25.374. That's in which quadrant? First. Where else does sine come out to a positive answer?
Second.
Second. So if there's another answer to this problem, it's in the second quadrant. It has to be. Think about it. It couldn't be in the third quadrant. Your angles in the third quadrant start at how big? And then go up to how big in degrees? Yeah?
180 to 270.
That's not going to work in a triangle, right? If you had an angle between 180 and 270, that's too big. And then if the third quadrant's too big, the fourth quadrant's even bigger. Those are angles between 270 and 360. Way too big for a triangle. So if there's another answer, it would have to be in the second quadrant. So what do I do with 25.374 to get the second answer? Yeah?
Subtract it from 180.
Subtract it from 180. So 180 minus 25.374. I'm not going to write that answer in the box yet. I'm going to put it off to the side. 154.626. I'm going to put a question mark. So that's the second answer if it works. Now remember, we're working with a triangle. So what do we know about all the angles in a triangle? They have to all add up to 180. So the question is, would this angle fit in the triangle with what was already given? No. You were already given a 40. This add 40 and 154 is 194. This angle is too big. This time, right? It came out too big. So if it comes out too big, you just cross it up. You don't use it. If it didn't come out too big, then what I would have done is something like this. Beta 1 and beta 2. And I would have done both answers. And what that means is if you get 2 answers for beta 1 and beta 2, you're going to get 2 answers for gamma and 2 answers for C. It's an all or nothing. Either everything has 2 answers, except what was given. That was given. You don't touch that. Just the stuff you're finding. It either all has 2 answers, it all has 1 answer, or they all have no answer. In this case, they all have just 1 answer. So beta is 25.374. How can I get gamma now? Rob? Yes, all I have to do is add up 40, and I get 65.374, and subtract that from 180. Now I know gamma is 114.626. So I added up the other 2 and subtracted from 180. Now I got a piece of information in the last row, which enables me to find what? C. Now I can finally get C. Okay. This part is just like we've been doing. Okay. To find C, I know obviously I'm going to use row C. Which other row should I use?
A.
Yep. Stick with row A because it's given. So you got sine 40 over 3 equals sine of 114.626. You have to use it. You have to. So if you got it wrong, then C is wrong. There's no way around it. So sine 114.626 over C. Okay, so when I cross multiply, what will C be? You don't have to tell me it's a decimal, just what times what divided by what. Chris?
3 times sine 114.626 over sine 40.
Over sine 40. Yep. And now we just type that in. Okay, so 3 sine 114. 0.626 divided by sine 40. So for side C, I get 4.243. I'm going to check and see if that makes sense in a second. Looks like that's the biggest side. Should C have been the biggest side? Yes, it was across from the biggest angle. Beta was the smallest angle. B is the smallest side. That looks good. If I add any two sides together, they should be bigger than the third. So like A plus B is 5. Yep, it's bigger than C. B and C comes out to 6.2. Yep, it's bigger than A, and so on. Oh, it looks good. And again, that would be another 3 answers on the test. So you're probably going to have one of each type we did. One of the angle, side, angle. You can write it either way. One of the angle, side, angle. Or if you want to write it backwards, you can. It's angle, side, angle. And one of the side, angle. Leave it in that order. Don't put it backwards. It's not nice. Okay. So any questions on that? All right. Does anyone need me to explain again how you figured out the second answer didn't work? Because I have it all written out. You just subtract it from 180 and see if it fits in the triangle. Right? How we get what? So the second answer?
Yeah.
So to check if there's a second answer, take the answer that you got and subtract it from 180. Why? Because that's the formula in quadrant 2. It's 180 minus your reference angle. Once you get that number, see if it's possible for the second angle to fit with the angle that was given. So we got 154. The angle that was given was 40. That's too big. That adds up to 194. And I think I wrote that right here. So that's how you get the second answer, 180 minus 25.4, whatever we got for something. When we subtracted it, we got that, but we were given 40. If you add what you had to start and the possible second answer, it's greater than 180. It's too big. So the other answer is too big. So chances are, if we practice one today where the other answer was too big, probably going to see something similar to that one on the test. Next time, we'll talk about the no solution case, which is easy, because right away you're done. And then we'll talk about the 2 solution case, which is longer. It's not harder, but you have to do every calculation twice. So there's 6 answers instead of 3. Any questions on that? Alright, so homework tonight is 5 through 8 in the book, 10 and 16, that's in the book, and solve these 2 problems. That's the first one. That's the second one. If I am here tomorrow, I will give you, I'll review the homework and we'll have the test. And I'm just going to write down a few things about the test that you might want to know. Okay, does everybody have the homework? All right, well, 2 things I actually emailed you yesterday about the test. So for the test, you can use an index card. This is really, I think, the last week where we're going to have this many formulas, so most likely no index card for the next test. So you can use an index card, and you can use a scientific calculator. There is no graphing we did at all this week. Right? So all the stuff today, it's just using a basic calculator. You're only going to need a calculator that has sine, cosine, tangent. I have 10 of them up here. So obviously there's like 24 of you. So if you have one, I see some people with them, that would be good. How many people have one of these, just a regular calculator? So we're good. If you borrow one, which we don't normally use these, you just scan your ID, you scan the barcode, you do the same thing to check it back. It's pretty simple. Okay, leave your homework out because I might have a minute to check it. If not, I'll check it tomorrow. Okay, so things you want to know for the test. So you want to know how to evaluate trig functions that are multiples of 15. Evaluate trig functions that are multiples of 15. So if it was in degrees, it would be something like find the cosine of 15. Okay. And you'd write it as a difference. I'm not going to go through the whole thing, but that's how you would start it off. So evaluating trig functions that are multiples of 15. If you get a problem that's in radians, my suggestion would be change it to degrees. That's going to make it easier. So you need to know the sine, cosine, and tangent, sum, and difference. There's two for each. Sine of a sum, sine of a difference, cosine sum, cosine difference, tangent sum, tangent difference. You can get around the tangent if you don't want to write it down, just with the sine and cosine. All right, you should be able to prove something like, is the example we did on Monday. It was like example 2 or 3. Let me just open, what did we do Monday, 7.5? Yes, like that. Should be able to prove something like example 2A from the notes on Monday, or example 2B. Should be able to do something like that. So prove example 2A and 2B from, what was that, 7.5. And as far as the Monday material, that's it. Okay, so next thing is solving trig equations. Solve trig equations. So that involves, you should know how to factor. You should know how to use quadratic formula if it came to one of those. And you almost always have to use inverse trig, like to take the inverse sine of both sides. I mean, pretty much you have to do that for today too. So that will involve inverse trig. Okay, as far as identities, to solve trig equations, sometimes you need to know some identities. You're not going to need to know the half angle. Don't write that. You're not going to need those. You're not going to need the double angle either. What you're going to need the sum and difference. I already mentioned those, but you also might need some of the basic ones we did. The reciprocal, the tangent, cotangent, and Pythagorean. Pythagorean are actually up on the board over there. The reciprocal is like if you flip cosine, you get secant. If you flip tangent, you get cotangent, stuff like that. So reciprocal, tangent and cotangent, and Pythagorean. The tangent one, that's like this. Sine over cosine equals tangent. Cotangent, flip it. And that's it for the identities. The last 10 questions on the test are going to be about the law of sines. Okay, so it's 10 questions on that stuff. You're going to have one of each type. Angle, side, angle. Angle, angle, side. And let's write it the other way. Side, side, angle. There we go. That would have 3 parts to solve it. That would have 3 parts. This one would have 4 parts. The reason it would have 4 is because I would ask you to solve for the 3 things, and then I would say how many answers does each part have? 1, 2, or none. The one we did today was 1. Right? So that's why the last part is 10. Right? So 10 questions, so more than half the test is on what we did today. And that's everything that's on the test. Okay. Any questions about what you can use or not use on the test tomorrow? So the next card's good. Regular scientific calculator, no graphing calculator. With the 6 minutes we have left, I'll just come check the homework real quick, and that's it.
Can you put the homework back up?
Yes.